Hello AP Physics 1, it's Mr. Ng and I have a video for you to show you how to manage all of your data as you're doing your dynamics lab, at least your first one. The first thing I did was I set up my independent variable. This column for force, this represents what I'm changing in lab. And what I changed was that little hanging mass that's kind of hanging off that string. Here, I put in 100 grams hanging off that mass, and then I put in 200, 400, 600, 800, and then 1,000. If you notice, it doesn't say 100, it says 1,000 because I multiplied it by 10 because it's in newtons, it's not in grams, right? 100 grams times the acceleration of gravity, which is 9.8, is around 1,000 newtons. So these guys are not in grams, they're in newtons. So all you got to do is multiply by 10. If you're real super nitpicky, you could actually multiply it by 9.8 and get much nicer numbers. That's fine. On top of that, for each of these independent variables, I collected my dependent variable, which is going to be the actual time. The time is not directly in the equation for Newton's second law, but from this time, I can get my acceleration, which is what I'm going to show you today. I'm going to show you the two little formulas you could put into Excel to get to acceleration. So here, I have all my times, and I need some average times. This part's really easy. I'm going to put in a function to find that average. That way you don't have to do it by hand. So I'm going to put equal to. That's a secret little button there. Just do equal to average, A-V-E-R-A-G-E, open parentheses. And I'm going to highlight all these suckers, right? So you can see it goes from E2 to G2, E2 to G2, close parentheses and equal. So there you go. That averaged it out for me. This is the average of all these guys here. Right? And now I'm going to grab this little bottom corner here. I'm going to drag it down, and it's going to just do that function over and over again. Does that make sense? That way I don't have to rewrite that equation over and over again. I'll show you again. So here, when you have one of these suckers done, move your cursor over to this little bottom right corner, and notice how it turns into a little cross. That's perfect. Not the hand, not the little arrow, this little cross. Hold down, drag down, and it does all of the math over and over again for you. That way, you're only spending a few seconds on this math. I don't like it looking all ugly like this, so I like going here and changing it into a number. That looks nice. Okay, so now I have all of my average times. Now, I can use my 1/2 AT squared equation and put in another function. First things first, I got to put in that distance. Each and every time was 0.7, meaning 70 centimeters, 0.7 meters, right? This has to be in meters here. I'll write that there. This is in meters. This was in newtons. And these are all seconds, obviously. All right, good. So here, these are all 0.7, so I'm just going to drag down, do that real fast. Okay, this is the equation that's the hardest to put in, so let me show you. The formula to find acceleration is equal to 2x over t squared, meaning this little box needs to be equal to 2x, 2 times the distance. I'm going to do open parentheses, 2 times this distance, close parentheses, divided by t squared. So I got to do this thing squared. And to do that squared, I'm just going to multiply it by itself times d2 again. And I'm going to put that in parentheses just so that Google doesn't get all confused. All right, do you see this? This is 2 times the distance, and then the times itself. That's basically squaring it. There you go. I have my acceleration. I'm going to drag this down, and I'm done. And I'm just going to turn this into a neat little number. Boom. So now, the larger the force, the larger the acceleration, right? So here, I can finally do one last little trick. I can graph this sucker. I'm just going to highlight this whole bit. Go here, I'm going to insert a chart. And then immediately Google always chooses the wrong chart for you. Almost always in science, you're going to do a scatter plot. So go to setup, go down here, scroll down, choose a scatter plot. Ooh, look at that neat line. And then notice that because I already had my tables already well organized, I have I have a y-axis, I have an x-axis, I have a title. All I need now is a trend line to do that. I'm going to go to customize. I'm going to go down to my series, I'm going to scroll down, add a trend line, boom, a nice linear relationship between acceleration and force. And if you find the slope of this thing, you're going to find that it's going to be the mass of your total system. Good? Hey, thank you very much for watching. Big takeaways is basically how to do this little equal sign. To find the average, just equal sign average and all the numbers you want to average, just highlight that. And then here, the hardest one is to find the formula for finding acceleration from time and distance. So here, I will just leave this up for a little bit. This is equal to 2 times the distance divided by the times by itself. Okay? Some of you don't like the times itself. You might want to do a caret. All right? And 2 means the same thing. It means to square it. It's the same number, right? Boom. Boom. All right? I'll just leave this here. Hey, thank you very much for watching. You guys are doing a great job.